students, welcome back to the next module. In this module, we'll see MCQs on graphical representation of SHM. So, let's start with our first question. The velocity and acceleration of a particle executing SHM have a steady phase relation. The acceleration leads velocity in phase pi. And the options are pi, minus pi by 2, plus pi by 2 and minus pi. So let's start with the solution. So we are actually going to find what is the phase difference between acceleration and velocity. So to begin with, students, we know the formula of velocity is a omega cos omega t. As we know, sin pi by 2 plus theta is cos theta. Therefore, this formula of V can be written as V is equal to a omega sin omega t plus pi by 2. A is minus a omega square sin omega t. In terms of sin omega t, I can write it as, we know the trigonometric formula, sin pi plus theta is minus sin theta, and therefore students, A becomes a omega square sin omega t plus pi. Now the phase of acceleration is omega t plus pi and the phase of velocity is omega t plus pi by 2. Let's go for phase difference. So let's subtract the phase of A and with the phase of velocity, which is omega t plus pi by 2. If I go for the next step, let's open that bracket. So it becomes omega t plus pi minus omega t minus pi by 2. Let's cancel omega t. Pi minus pi by 2 is pi by 2, and hence students, the phase difference is pi by 2, rather plus pi by 2. Therefore, our correct option is option C. Students, the same conclusion we have already seen in the graphical representation of SHM. Phase difference between acceleration and velocity is pi by 2. Let's go for the next question, students. The equation of motion of the particle performing SHM is as shown in the following graph, and we have 4 options given to us. Now, all 4 options are in terms of standard equation of displacement. Now, to begin with, students, whenever graphical questions are given, you always first know what is the nature of this graph. You can clearly see this graph is displacement versus time. The next thing, what all things we can note from this graph. If you look at this graph, you can see the peak values are plus and minus 4. For x versus t graph, the peak value is always plus and minus a. That means this peak value here is nothing but amplitude. So a is equal to 4 centimeter. Also, you can see on x-axis, the values of small t is written. Now, you can clearly see this is nothing but one cycle of this curve. We know time taken to complete one cycle is time period. So, second thing I can conclude from this graph is that time period is 1.2 seconds. Now, since all the options are in terms of x, let me write the standard equation of displacement first, that is x is equal to a sin omega t plus alpha. Since a is equal to 4, let's check. Look at option B, students. You can clearly see amplitude there is 1, whereas the answer for this is amplitude should be 4. Therefore, B cannot be the answer. Now, since this is a cosine curve, we should know cosine curve, that means your initial angle alpha is pi by 2. Now, if we look at option A, which is x is 4 sine 5.2 t, the coefficient of t is always omega. That means alpha here is 0. Therefore, option A cannot be the answer. Likewise, alpha for C is also 0, and hence C cannot be the answer. So, A, B and C cannot be the answer. Therefore, students, the correct answer is option D. So, by elimination method, we have solved this MCQ without actually going for the solution. Now, we can also prove how come it is 5.2t. As I told, the coefficient of t is always omega. That means, let's find omega first. So, as we know, omega is 2 pi by t. Let's put the value of t, which is 1.2. 2 pi is 2 into 3.14 upon 1.2, which is 6.28 upon 1.2. Now, students, if I divide this 1.2 into 5 is nearly in the range of 6. As in all 4 options, the nearest option is 5.2. So, it is no doubt omega will be 5.2 radians per second. I know this is the standard formula of x. Let's put down the respective values. So I get x is equal to 4 sine 5.2t plus pi by 2. Sine pi by 2 plus theta is cos theta, and students, therefore it is 4 cos 5.2t, which is nothing but option D. Let's see the next question, students. If a graph is drawn for acceleration versus displacement of simple harmonic motion, it is a sine curve, cosine curve, straight line, or ellipse. Students, as soon as you see the word acceleration graph, don't directly jump into the conclusion it will be either sine or cosine. Always look at the question first. This is not A versus T, this is acceleration versus displacement x. A versus T graph can be sine or cosine, but not A versus x. Therefore, A and B options are wrong. Now, whenever the graph is asked, first of all, we should know relation between the two terms. So, the relation between A and x in SHM is acceleration is minus omega square x. We know omega square is constant. Therefore, students, it can be written as acceleration is directly proportional to minus x. We know in mathematics, when one quantity is directly proportional to another quantity, the nature of graph always is, yes, it is a straight line graph. Therefore, the graph has to be straight line, which is nothing but option C, students. So, the graph is a straight line. Now, if you plot this A versus x graph, no doubt it's a straight line, but it is a straight line passing through second and the fourth quadrant, as slope is negative here, minus x, so slope has to be negative. That's all in this module, students. See you in the next module.